Hey guys, in this video we're going to talk about exponents and order of operations. So first of all, what is an exponent? An exponent is the number of times a base number is multiplied by itself. So here's an example of an exponential or an exponent expression. We have a base 4 and we have an exponent of 3. 3 is the little number that's written at the top. That's our exponent. And what this means, how we can say this, is 4 raised to the third power. That's what that means. So all we do is take the base and multiply it by itself, however much the exponent is. So since the exponent is 3 and the base is 4, we're going to multiply 4 by itself 3 times. Right? That's what the exponent tells us. And so 4 to the third is 4 times 4 times 4, and 4 times 4 is 16. 16 times 4 is 64. So 4 to the third is going to be 64. That's our answer there. All right, so let's do some practice writing these expressions as exponents. So looking at the first one, we can see that our base is our number that's being multiplied. So our base is 2. And how many times is it multiplied by itself? It's multiplied 1, 2, 3 times. So this is going to be 2 to the third. All right, so that's how we would write that as an exponent. And we could evaluate this if we want to, but for now we'll just leave it as an exponent. Okay, let's look at number 2. What is our base? Our base is going to be the number that's being multiplied by itself, so that's 3. How many times is it multiplied by itself? It's multiplied by itself 2 times, so that is our exponent. All right, looking at number 3, we have 8 times 8 times 8 times 8 times 8 times 8. So our base is going to be 8 because that's the number being multiplied by itself, and our exponent is going to be 1. Let's see, 1, 2, 3, 4, 5, 6. It's going to be 8 to the 6th power. What about number 4? How can we write this guy as an exponent? Well, it's only being multiplied by itself once, right? So it's just 9. So our base is going to be 9. That's our number, and it's to the first power. All right, so just 9, right? Number 5, we have negative 3 times itself 4 times. So our base is negative 3, and it's being multiplied by itself 4 times, so that's our exponent. Okay, let's go ahead and do it the other way and expand these. So 2 to the 4th power, our base is going to be 2, and our exponent is going to be 4. So this is telling me to multiply 2 by itself 4 times. So this is going to be 2 times 2 times 2 times 2. Okay? And we can evaluate this if we want to, but for now we'll just leave it. Negative 8 to the 2nd power, or sometimes we'll say negative 8 squared, means negative 8 times negative 8. We learned last time in the last video that a negative times a negative is always positive, so that would end up being positive 64. Number 3, our base is going to be 4, and it's saying multiply 4 by itself 6 times. That's what our exponent says. So this is going to be 4 times 4 times 4 times 4 times 4 times 4. So that's how we expand each of those. Okay, so let's talk about some special properties of exponents. The first property that you need to remember is that if you raise a power to 0, it's always going to equal 1. So for example, 2 to the 0 power equals 1. All right, you can raise anything to the 0 power and get 1. Say you raise 100 to the 0 power. This is equal to 1. Okay, so that's the first property you need to know. The second property is if we have a fraction raised to an exponent, we can simply distribute that exponent inside to the fraction. So a over b all raised to the c is the same thing as a to the c over b to the c. Let's do an example with that. So looking at this example, our fraction is 2 over 3. That's our base, and our exponent is 4. So this is going to be 2 to the 4th over 3 to the 4th, using this property right here. Now, another way that you can see that is if we take 2 over 3 and multiply it by itself 4 times, that's what this means. It says, hey, take the base, multiply it by itself 4 times. That's the definition of an exponent. We get this, right? Well, look on top. 2 times 2 times 2 times 2 is base 2 raised to the power 4. That's 2 times itself 4 times. And on bottom, we have base 3 multiplied by itself 4 times. So that's 3 to the 4th. So that's how we get that. So that's one other property that we have of exponents. The other property that we have, so we have negative exponents. If we have a negative exponent in the denominator, it becomes if we have a negative exponent in the numerator, it becomes a positive exponent in the denominator, and vice versa. So if we have x to the negative a, this we can just put over 1 and make it positive. If, on the other hand, we have 1 over x to the negative a, we can move it to the top and make it positive. So let's do some examples with that. So our directions say simplify using positive exponents. So this is 3 to the negative 2, so I simply put it over 1 and make it positive, okay? So this is 1 over 3 to the 2, and I'm not going to simplify fully, but I just want to show you, how these two expressions relate to each other. What about 4 to the negative 3? Well, once again, this is a negative exponent, so what we can do to make it positive is bring it to the bottom over 1, or under 1, and make the exponent positive. So 4 to the negative 3 is the same thing as 1 over 4 to the 3. Okay, 1 over 2 to the negative 8. So to make it positive, we can this time bring it to the top. If it's negative on bottom, we can bring it to the top to make it positive. If it's negative on top, we can bring it to the bottom and make it positive. And keep in mind, well, actually, I'm going to save that. Okay, so we can bring this to the top to be 2 to the positive 8. Okay, 2 to the positive 8. So that's our answer there. All right, here we can use our fraction property. So 1/2 to the third is the same thing as 1 to the third over 2 to the third. If we wanted to, we could simplify this to 1 over 8, right? 2 times 2 times 2 is 2 to the third. That's going to give us 8. And 1 times 1 times 1 is 1. So that gives us a value of 1 over 8. Okay, let's look at number 5. So we can first distribute this negative 2 to the exponents of both 3 and 4. So this is the same thing as 3 to the negative 2 and 4 to the negative 2. And to make these exponents positive, I can bring this one down here, and I can bring this one up here, right? So this becomes 4 to the positive 2 over 3 to the positive 2. Which is 16 over 9. 4 squared is 16, 3 squared is 9. Okay. Negative 3/8 to the 0. Well, anything to the 0 is 1. That's one of our special properties. 1/6 to the negative 3. So I can distribute this negative 3 so that it's 1 to the negative 3 over 6 to the negative 3. And to make these positive, I can bring the top to the bottom and the bottom to the top, right? So this becomes 6 to the 3 over 1 to the 3, which is just 6 to the 3 over 1, which is, let's see, 216. Okay. All right, negative 2 raised to the 6th power. So I'm going to put this in my calculator. And I'm not moving anything to the bottom anywhere because the base is negative, not the exponent. The exponent's still positive. So I'm just putting this in my calculator, negative 2 raised to the 6th power, and I get 64, okay? Now, if you were to put, this is a different expression. Because there's no parentheses around that negative 2, it's saying do this first and then add the negative. Okay, so 2 to the 6 is 64, and then add the negative. So these two expressions have a subtle difference, and that's the parentheses. All right, now that we've talked about exponents, I want to talk a little bit about the order of operations. So some people know this as PEMDAS, and so the the phrase that you can remember this by is please excuse my dear Aunt Sally. So PEMDAS, please excuse my dear Aunt Sally. And what PEMDAS is mathematicians agreed upon an order which to complete operations like addition, subtraction, multiplication, and division. And the order that we do it is indicated by PEMDAS. So P, we do our parentheses first. E, that means we do exponents after that. MD, so we do multiplication or division left to right, whichever one comes first. So if division comes before multiplication, we can do that. They're interchangeable. And then AS is addition or subtraction from left to right, depending on what comes first. So let's do a bunch of examples with this. Let's look at number 1 first. So using PEMDAS, we have 10 minus 3 times 2. And so the order of operations says I want to do multiplication before I do addition and subtraction. So the first thing I need to take care of is this negative 3 times 2. Now what's negative 3 times 2? Well, that's going to be a negative 6. So I need to take care of that first. So again, PEMDAS says, hey, do this multiplication before you subtract. Now we can do 10 minus 6 is going to be 4. So that is our answer there. If we were to do this the other way, like if we were to just multiply, or if we were to just go from left to right, 10 minus 3 is 7, 7 times 2 is 14, which would be technically wrong. So we want to make sure we are using our order of operations here. Okay, number 2. So I see a parentheses, and that's the first thing we want to do. We want to do everything in the parentheses first. So 9 plus 3 is going to be 12. And so once we do that, that can come out of the parentheses because we have nothing left in it, right? We just have this 12. So it can come out, and then we're still left with divided by 6 on the outside. So 12 divided by 6 is going to give us our final answer of 2. Let's look at number 3. Let's take a look at the operations here. So I see subtraction, division, multiplication, addition. So PEMDAS says, hey, do multiplication and division first, whichever comes first left to right. And what comes first is division. We have negative 72 divided by positive 6, and that's going to give us a negative 12. So this is going to be 84 negative 12 times 2 plus 1. All right, so now going from left to right, we now want to do multiplication before subtraction or addition. So the next thing we want to take care of is negative 12 times positive 2. And that's going to give us a negative 24. So we carry that down. So we get 84 minus 24, and then we still have plus 1. At this point, all we have is addition and subtraction, and we want to go from left to right. So 84 minus 24 is going to be 60. So that was this. And then 60 plus 1 finally is going to give us our answer of 61. So that's our answer there. All right, let's try some more. Let's do a bunch of examples. Okay, so whenever I am simplifying or evaluating an expression, basically what I'm doing is I'm condensing it. I'm trying to make it smaller, and I'm trying to figure out what number I get when I do all of these operations. Now, the first thing you want to do before you do any kind of PEMDAS is, and maybe I'll actually put that right over here so you guys can see it over here. The first thing I want to do is, if I have double signs next to each other, I want to change those first. Remember from the last unit, if we have two negatives next to each other, it becomes a positive. So that's what I'm going to do first. I'm going to rewrite this as negative 2 these double negatives become a positive 1 times 6, okay? So PEMDAS says, hey, we need to do multiplication before we add. So we need to do 1 times 6 first, and that's going to give us 6 and carry down everything else. Finally, we compute negative 2 plus 6, and that's going to give us positive 4. So subtract 6 minus 2, take the sign of the larger, that's 4. Excellent. All right, let's look at the next one. So I see double signs. I see a plus and a minus directly next to each other. And we know when we see a plus and a minus directly next to each other, it becomes a minus, right? So what this becomes is 4 minus 6 divided by 3, okay? Now I want to do division before subtraction. So I want to go ahead and do negative 6 divided by 3 first. And that's going to give us negative 2. So I get 4 minus negative, or 4 negative 2. Finally, we subtract. 4 minus 2 gives us a final answer of 2. Okay, let's look at the next one. So I see parentheses, so the first thing I want to do is take care of what's in parentheses. So what's in parentheses is negative 6 divided by positive 2. That becomes a negative 3. So let me carry that down. And just keep the parentheses as they are. Okay. All right, next comes exponents. All right, we did parentheses. The next operation in the order is exponents. So let's take care of the exponents first. Notice that I don't want to do the double negative becomes a positive right here because of this exponent. I want to make sure to do the exponent before I do that. So let's go ahead and do this. 2 squared, 2 to the second power becomes a 4. We still have this minus on the outside. And negative 3 to the third power, let's write it over here. This is in parentheses, so this is negative 3 times itself 3 times. Now, negative 3 times negative 3 is a positive 9. Positive 9 times a negative 3 is a negative 27. So this becomes negative 27. Now, since I don't have an exponent anymore, I can make these double negatives become a positive. So let's go ahead and do that. So this becomes 4 plus 4. The double negatives make a positive, 27, and I can just add left to right. So 4 plus 4 is 8. 8 plus 27 is 35. Yeah, so that's our answer, 35. All right, number 7, we want to take care of anything that's in our parentheses first, and we see it's all addition, so we can add left to right inside the parentheses. So 6 plus 3 is 9. 9 plus 1 is 10. So this all becomes 10 to the second power. Now what's after parentheses, please excuse, is exponents. So we want to do 10 squared first. So 10 times 10 is 100. So this becomes 1/4 times 100. 1/4 times 100 is going to be 25. Okay. All right, let's go ahead and look at number 8. So we want to go ahead and take care of this parentheses first. 3 and 2 make 5. So this is going to be 5 squared minus 7, all divided by 9. And you actually want to treat your numerator and denominator as grouping symbols. So like the numerator is its own group, even though there's no brackets or parentheses, and this guy is its own group. So we kind of want to treat these like their own set of parentheses. So I'm going to go ahead and evaluate the top first. So doing my exponent first, 5 squared is going to give me 25, minus 7 on top, and I just have a 9 on bottom. 25 minus 7 on top is 18 over 9. Now remember what this fraction bar means. It just means division. So 18 divided by 9 is 2, and that's our final answer, completely simplified. All right, let's move right along and look at number 9. So first things first, PEMDAS, parentheses comes first. So I want to first do negative 9 divided by 3. That's going to give us a negative 3. So this is negative 3 squared minus 1. I'm just carrying everything else down. And order of operations says, hey, let's do our exponents next since we took care of the parentheses. Well, the first exponent I see is negative 3 squared. That becomes a positive 9, but notice that I still have a negative on the outside. So this is going to become a negative positive 9 minus 1, and then 2 to the third. Notice the negative 2 isn't in parentheses, so I just leave it hanging out on the outside. 2 to the third is 8. 2 times 2 times 2. So this is where we're at, negative 9 minus 1 minus 8, and we can just go from left to right. Negative 9 minus 1 is negative 10. Negative 10 minus 8 is negative 18. So that's our final answer. All right, let's do one more on this page. We have this mess right here. So the first thing I'm going to do is see if I have any parentheses. I have this parenthesis, but it's kind of attached to the exponent, so it doesn't really count. The next thing I want to do is my exponents. So notice this negative 2 is not in parentheses, so I'm just doing 2 to the third and keeping the negative in front. So this becomes 2 minus, and then 2 to the third becomes 8. Minus, now this guy is in parentheses, so this guy, negative 1 squared, is the same thing as negative 1 times negative 1, which is positive 1. So we still have this negative on the outside, but what this becomes right here is positive 1. So I'll just leave it like that, times 2. Okay, next thing in my order of operations to do is multiplication. So I want to do negative 1 times 2, and that's going to give me a negative 2. So this becomes 2 minus 8 minus 2. Then I'll just move from left to right and subtract. So 2 minus 8 is negative 6. Negative 6 minus 2 is negative 8. So my final answer is negative 8. Let's do some more. I encourage you to pause the video and see if you can do these on your own. Okay, so first thing I want to take care of my parentheses. So 6 and 4 make 10. So this becomes a 10 squared. And then if you have different operators, like addition and division, in a set of parentheses, you want to do PEMDAS within the parentheses. So the first thing I need to do is division. So 10 divided by 2 is going to be 5. So this carries down to be 11 plus 5. Okay, now I can do 11 plus 5, and that's going to be 16. So this becomes 10 squared, that's this, plus 16, right? Now that I'm done with my parentheses, I can do the exponent. So 10 squared is 10 times 10 is 100, and then 100 plus 16 gives me a final answer of 116. Let's look at number 12. So we have parentheses right here, it's red parenthesis. And within the parentheses, we can do a few things. So we can first change this to a negative, right? Because a positive and a negative next to each other without exponents is just a negative. So that becomes like that. Now it looks a little bit cleaner. Now what we want to do within the red set of parentheses is the exponent, because exponent comes before subtraction. So negative 3 squared is negative 3 times negative 3, that's a positive 9. So this becomes 2 times positive 9 minus 1, all in parentheses. And actually this shouldn't have been there because we already got rid of it. So there we go. So working in the parentheses, 9 minus 1 is 8. So this becomes 2 times 8. And 2 times 8 is going to give us a final answer of 16. Okay, let's do a few more. So I see some parentheses. I see a pair right here and a pair right here, outer parentheses. So if I look at the first set, 20 divided by -10 is going to give us a -2. And then looking at the second set, first of all, these double negatives become a positive, so I can just carry that down here. This is going to be 2 to the third plus 1. And 2 to the third is 8. So I can carry this down, -2, 2 to the third is 8, plus 1. So this is 9 times -2, and that's going to give us -18. All right, let's do this one. So parentheses, I'm going to do whatever is in there first. And PEMDAS says do the division first. So within the parentheses, 6 divided by -2 is going to give us -3. And I still have plus 3 to the 3 on the outside. Now, within the parentheses, -3 plus 1 is -2. So I have 8 times -2 plus 3 to the 3. Now, PEMDAS says, so this is multiplication, right? And this is an exponent. So I want to do the exponent first. And 3 to the third power, 3 times 3 times 3 is 27. So this is going to give us 8 times -2 plus 27. Now I want to do multiplication. That's the next letter in PEMDAS. So 8 times -2 is going to give me -16. And finally, -16 plus 27 is going to give me a final answer of 11. Okay, so let's go ahead and look at this example. So I see some parentheses here. I see a big set right here. So I'm going to work with this guy first. First thing I want to do is I want to do the exponent in there first. So -2 squared is -2 times -2, and that's going to give us a positive 4. So I'm just going to carry that down, carry everything else down as well. Okay. Now, inside the parentheses, 4 minus 2 is going to give us 2. And we'll carry everything else down. All right, next comes the exponent. So 2 squared is 4. So this becomes 2 times -2 plus 4. Next comes multiplication. 2 times -2 is -4. So that becomes -4 plus 4, giving us a final answer of 0. All right, now we have some fractions. So order of operations says we better multiply before we subtract. Okay, so let's do this multiplication first. Don't forget the signs in front. So we have -1/2 times 5/6. Let's look at the diagonals to see if we can cross simplify. I don't see anything, so we just multiply straight across. -1 times 5 is -5. 2 times 6 is 12. Okay, so what this becomes in green is -5/12. Okay, now we can carry out the subtraction. You can find common denominators, or you can put in the calculator. I'm lazy, so I'm going to put in the calculator. And I am getting 11/24 simplified. So this is my final answer. All right, let's do 2 more. So evaluate. We want to simplify this fully. Again, we're thinking of the numerator and denominator as their own little groups. So first thing on the numerator, 7/3 minus 3/1. Well, the common denominator I can get is 3. So I can change 3/1 to have a denominator of 3 by multiplying top and bottom by 3. So 3/1 is secretly 9/3. And if I subtract the top, 7 minus 9 is going to give me -2 on top, and I have 3 on bottom. All right, so the numerator becomes, so this is my numerator, this becomes -2/3. Now for my denominator, I have 1 plus 5/6, 1/1, that is, and I can change 1/1 to have a denominator of 6 pretty easily. So I have to multiply top and bottom by 6 to do that. So 1 is secretly 6 over 6. And if I add straight across, 6 plus 5 is 11, and that's going to be over 6. So this is my denominator. So my numerator was negative 2 over 3. My denominator was 11 over 6. So let's do that. So numerator over denominator. And remember what we do, we call this a complex fraction when we have the big bar there. This is just division, right? So what do? We keep, change, flip, keep the top, change this to multiplication, flip the bottom. And I can cross simplify the 3 and the 6. I can say, well, 3 goes into itself once and 3 goes into 6 2 times. Multiplying straight across, we get negative 2 times 2 is negative 4 over 1 times 11 is 11. This is my final answer. Let's try one more here. So again, we're going to group the top and the bottom separately. So for the top, we have 1 minus 9 over 2. I'm going to get 1 to have a denominator of 2 by multiplying top and bottom by 2. So this is secretly 2 over 2 minus 9 over 2. 2 minus 9 is negative 7 over 2. So this is my numerator. For my denominator, I have 7 over 4 plus 2 over 1. I can change the 1 to a 4 pretty easily. So I'll multiply top and bottom by 4 to give me an equivalent fraction of 8 over 4. So this problem is actually 7 over 4 plus 8 over 4. So 7 plus 8 is 15 over 4. So this is my denominator. And now we can put it all together. So numerator over denominator. So we keep the top, keep, change, flip. Change division to multiplication and flip the second fraction, the bottom one. So that's going to be 4 over 15. I can look on the diagonals to see if I can cross simplify, and I can right here. 2 goes into itself once and 2 goes into 4 twice. Multiplying straight across, I get negative 14 over 15, and this is my final answer.